Okay, send me the answers for the question. Send the answers again. Someone to give me the answer that you got here. What is the answer? Yeah, 1.35 or what? The other one is what? 7.935. So those are the break-even points, which you can either round up and say it is 2 units or 8 units. Those are the break-even points. The break-even points. Okay, so the next question is the level of output that maximizes profits. So you need to come here and say profit. Profit is revenue minus cost. So the revenue is 0.3 Q square minus 5Q. You minus the cost. The cost is 1.7 Q square minus 18Q plus 15. So opening the brackets, this is 0.3 Q square minus 5Q minus 1.7 Q square minus 18Q, that is plus, and this is minus 15. So this goes back to what we had. It becomes 13Q minus 1.4 Q squared minus 15. That is the same function we had here, because at break-even point, profit is also equal to 0. So remember, this is our pi. Then you tell us for maximum profit, the differential with respect to Q is 13Q minus 1.4 Q squared minus 15 is equals to 0. So when you differentiate, this becomes 13 minus 2.8 Q is equals to 0. So from there now, tell me what is Q. From there, tell me what is Q. Yeah, 4.64. So Q is 4.64 units. 4.64 units. And thus, profit is equal to 13 multiplied by 4.64 minus 1.4 times 4.64 square minus 15. Minus 15. So get your answer there as the maximum profit. The next question is May 2021, question 1B. May 2021, question 1B. May 2021, question 1B. It says that Comp World Limited assembles and sells computers. The company estimates that if it optimally assembles computers, it could sell between 1,100 and 2,000 computers per month, and the monthly revenue in thousands of shillings over this range of sales would be represented by the function. So we are given that function. The company estimates that its marginal cost in thousands would be represented by that function. The fixed cost is 100,000 per month. If it is assumed that all the computers assembled in the given month are sold within the same month, get the total cost function. So total cost function, this one we shall get it as TC being the integral of the marginal cost, that is 200x squared minus 200x plus 400 with respect to x. With respect to x. So the total cost here will be 200x squared plus 1. We divide by 2 plus 1. Then you minus 200x raised to power 1, you add back 1. You divide by the new power plus 400x currently raised to power 0, you add back 1. You divide by 0 plus 1. You add C, the constant of integration, and this settles as 200x cubed out of 3 minus 100x squared plus 400x plus 100. The fixed cost is 100. The fixed cost is 100. The next one is total revenue. Total revenue function. Now the total revenue function R is already given as 1,000x minus 200x squared minus 200x squared. So when they then proceed and tell us to get total profit function, we will say pi is equals to 1,000x minus 200x squared. You minus 200x cubed out of 3 minus 100x squared plus 400x plus 100. So we open these brackets to get pi is 1000x minus 200x squared minus 200x cubed out of 3 plus 100x squared minus 400x minus 100. So when you proceed and say, write terms together, there is this 1000 to join this 400, so that we are left with 600x. Then this 200 square to join this 100, so that we are left with minus 100x square. This cubed has no a colleague, so it remains just like this 100 will remain. So that is the profit function. If that is the profit function, the next one now is optimal profit or optimal output. Optimal output. Now the optimal output, we will say the differential with respect to x of 600x minus 100x squared minus 200x cubed out of 3 minus 100 will be equal to 0. That is where we shall get optimality. So if we differentiate, this settles at 600 minus 200 minus 200x is equals to 0, x squared minus 200x squared. Or this is 200x minus 200x minus 200x squared. So using quadratic formula, our x, because we have just written the formula in the other question, so we can just substitute straight. You have to send a minus, that becomes positive 200 plus or minus 200 squared minus 4 times a, which is minus 200 times c, which is 600. You get the square root. Then you divide by 2 times a, which is minus 200. Once again, solve and give me that answer. Waiting for the answer. Minus 1.3 or 2.3? Minus 1.3 or 2.3. So because we cannot have negative units, so we settle for x to be equal to 2.3 units. So that is the optimal output. So when they want optimal profit, you say pi is equal to, you take this profit function, the profit function is here, 600. So 600 times 2.3 minus 100 times 2.3 square minus 200 times 2.3 cubed out of 3 minus 100. So get your answer there. And then as we take a small break for prayers, after the break, so I give you 5 minutes for prayers. And then after that, you attend this question, November 2021, question 1A. So you attend this one, November 2020, question 1A. Okay, so I believe you have managed this one. Any problem with it? Any problem? Good. If you are okay with that, make sure you also deal with this one. Let me do this. November 2019. Let's go to November 2019. November 2019. Question 2A. November 2019, question 2A. Inasema the profit function for a given company is given as follows, where X presents time in months. So you are required to get the cumulative profit in the break-even interval. So for us to solve that, we will begin by saying again, at break-even point, profit is equal to 0. That is 10x minus x squared minus 5 is equals to 0. So using quadratic formula, x will be minus 10 plus or minus 10 squared minus 4 times a, which is minus 1 times minus 5. You divide this by 2 times minus 1. So quickly solve and give me the 2 answers. Solve that and give me the 2 answers. Solve and give me the answers. Okay, 0.5 and 9.5, good. 0.5 and 9.5. So when they ask for the cumulative profit, you integrate now between 0.5 and 9.5. You integrate this 10x squared minus x squared minus 5 with respect to x. So this is a case of definite integration. So this becomes 10x 2 plus 1 out of 2 plus 1 minus x squared plus 1 out of
10x is not square.
Oh, 10 is not square. Thank you. 10 is not squared, thank you. So this is 1 plus 1. So this is also 1 here. Minus 5x is power 0, you add back 1. Then you say 1 plus 0. In the ranges of 0.5 to 9.5. In the ranges of that. So if I come back here, I'll be able to continue and say this is 5x squared minus x cubed out of 3 minus 5x in the range of 0.5 to 9.5. So this one becomes 5 times 9.5 squared minus 9.5 cubed out of 3 minus 5 times 9.5. You minus 5 times 0.5 squared minus 0.5 cubed out of 3 minus 5 times 0.5. So that is what will give us the cumulative profit when we are told to integrate. Waiting for the answer. Oh, 4.7. Okay, so if that is what we have for 4.7, the next one is for maximum profit. Now this is our maximum profit. For maximum profit, if you differentiate with respect to x, this 10x minus x squared minus 5, and you say is equals to 0, then you get 10 minus 2x is equals to 0, and that gives you x is 5 units, and thus profit should be equal to 10 times 5 minus 5 squared minus 5. That will give you the maximum profit. I don't know whether this answer was correct. Because this one, give me the answer here. What's the answer here? 20. So, Marseille, you are saying this one is 119.25. So, you will confirm which one is which. Confirm. Okay, so I think that is good. On your own, you shall handle November 2018, question 2A. November 2018, question 2A. Make sure you look at that question. The next one that I want to handle is here, May 2018, question 2B. May 2018, question 2B. May 2018, question 2B. It says that BC Limited operates two factories, namely X1 and X2. Both factories deal in the production of product named Guzo. The joint cost function for production of product Guzo is given by that. We are required the quantities of product Guzo that should be produced by factories X1 and X2 respectively in order to minimize cost. Now this one is what I told you is a case of presence of constraints. Presence of constraints, budget constraints. When there is a budget constraint and you still want to maximize, how do you go about it? The first thing is to form a grade. So the grade equation is given as f of xy. You multiply by g by, you add alpha g of xy. Alpha g of xy. Now f of xy is the function whose value you want to maximize. Is the value whose value you want to maximize or to minimize. So this is the one that is given there as 2q1 square plus q1 q2 plus q2 square plus 500. That is the function that we want to maximize. Then g of xy is the constraints. We are told there that BC has received an order to produce 200 units. What that means is Q1 plus Q2 in whichever way they will give us 200 units. They will give us 200 units. So this is then normally written as Q1 plus Q2 minus 200. So with that now, you then come here and say that our grade will be 2Q1 square plus Q1 Q2 plus Q2 square plus 500. Then you say plus lambda. Lambda is the rate of change. You multiply by g of xy, which is Q1 plus Q2 minus 200. Minus 200. So if you open these brackets, L, you get 2Q1 square plus Q1 Q2 plus Q2 square plus 500 plus lambda Q1 plus lambda Q2 minus 200 lambda. Then from there, you differentiate the grade with respect to Q1. This is a case of partial differential. So this one becomes 4Q1, and this one becomes Q2. This one does not have Q1, 0. This is also 0, but here we have alpha. So plus alpha. Hapa hatuna Q1, hapa hatuna. So you say this is equal to 0, and you call it equation number 1. Equal to 0, and you call it 1. Then you proceed and tell us the differential of L with respect to Q2. Now this one does not have Q2, but this one has. So tunaachiwa Q1. This one becomes 2Q2. Hapa hakuna, but here we have, so it becomes plus lambda. This one we don't have Q2, so this is 0. And you call it equation number 2. The differential with lambda, or the differential grade with respect to lambda, goes as the next independent variable. Now all these do not have lambda. Imeanzia hapa, so tutaachwa na Q1 plus Q2 minus 200. This is 0, and you call this equation number 3. You call that one equation number 3. Then you proceed and say, removing lambda from 1 and 2. Removing lambda from 1 and 2, I will have 4Q1 plus Q2 plus lambda is equals to 0. Then Q1 plus 2Q2 plus lambda is equals to 0. Now this one, you minus. So this remains as 3Q1 minus Q2 is equals to 0. And this one, you call it equation 4. That one, you call it equation 4. Then you say removing Q2 from 3 and 4. We have Q1 plus Q2 equals 200. So 3Q1 minus Q2 equals to 0. When you change this one to this other side, now I say plus. So this becomes 4Q1 is equals to 200. And then it follows that Q1 must be 50 units. Q1 must be 50 units. Then using equation 4, we will say 3Q1 minus 50. Sorry, that is 3 times 50 minus Q2 is 0. So it means that Q2 must be 150 units. That is the answer those are the answers that are required. I think we are okay with that. Now let's go to the question of, it is November 2015, question 5C. November 2015, question 5C. Now, in that question, we have the value, we will have the midpoint, which will become our X. We have the invoices, which will become our F. We will have a column of F multiplied by X, or maybe I can start with the cumulative frequency. Cumulative frequency. Then I can have Fx, then Fx squared. I think those are the columns that I require for me to get what I want. Then I will have totals. So this is midpoint. Midpoint, you add the two limits, divide by 2. So this is 50. This is 150, 250, 350. So this is 20. This is 18. This is 22. This is 15. This is 9. This is 8. 4, 2, and 2. So first of all, give me, we can do that as accumulate. So this is 20, 20 plus 18 is 38, plus 22 is 60, plus 15 is 75, plus 9 is 84, plus 8 is 92, plus 4 is 96, 98, and 100. So the total here is 100. So give me the total of fx. Give me the total of fx. Waiting for this total of fx. The total of fx. $28,700. Good. Let's now go here and give me the total. And remember, here you had said 50 times 20. Now here it is 50 times 50 times 20, because x is squared. Then here it is 150 times 150 times 18. Those values are huge. You can just put them in the calc and give me the answer straight. Yeah. figures. You are taking too long to give me the figure. Hey, where are the figures? Okay, 12,170,000. Good. So what I want us to do using this data, number one is to remind ourselves how to compute the mean. X bar is sum of fx. We divide by sum of f. That's how we compute the mean. Yes, I can see those figures. Good. Confirmed. So the mean is going to be given as 28,700. You divide by the frequency, which is 100. So that gives us a mean of 287. That gives us a mean of 287. The next thing that I want us to compute is called variance. It's called variance. Now, variance is given as sum of fx squared. You divide by sum of f minus sum of x, sum of f, which is squared. So this will be 170,000. You divide by 100 minus 287 squared. So give me that value. That 9,331. Then we compute someone else known as standard deviation. Now, standard deviation delta is simply the square root of the variance. So give me the square root of that answer. Standard deviation is simply the square root 198.32. That is the standard deviation that I'm getting. The next item, anaitwa coefficient of variation. Now CV is given as standard deviation. You divide by the mean times 100. So the standard deviation is 198.32. The mean is 287 multiplied by 100. (69.1%). 69.1%. The next thing that I want us to get is called median. Now, median, M is given as L plus N out of 2 minus CF. You divide by F, you multiply by W. That is how you get the median. From there, we say N out of 2 is the total frequency, which is 100 out of 2, that is 50. So that will give you what we call the median class. The median class, unakuja hapa kwa cumulative frequency, you look for where 50 is. So 50 is in this class, hapa kwa 60. So if you are here, the class is 200 to 300. The class is 200 to 300. So our median then will be, the lower limit is 200 plus 50 minus the cumulative frequency above. The cumulative frequency above is 98. You divide by the frequency of that class, which is 22, multiplied by the width. The width is the difference between these two classes. You can see it is 100. Is 100. You be the figure. $254.55. 254.55. The next one is coefficient of skewness. Coefficient of skewness. Now the skewness is given as 3 brackets mean minus median. You divide by standard deviation. divide by standard deviation. So this becomes 3 brackets, the mean 287 minus the median 254.55. You divide by 198.32. Divide all this by 198.32. .49. So that means we have positive skewness. That is positive skewness. The next thing that I want us to remind ourselves is how to get the mode. Mode is given as L plus F1 out of F1 plus F2 multiplied by the width. Multiplied by the width. So the model class is the class with the highest frequency. It's the class with the highest frequency. So we come here and pick the highest frequency as this, 22. So that is the class of 200 to 300. 200 to 300. So F1 is given as F0 minus I should have used B1 and B2. But now that I've used F1, let's go straight instead of changing the initials. The F1, you get the mode of frequency, that is 22. You minus the frequency of the class above, 18. So that gives us 4. Then F2, it is the frequency. You minus the one that is below. F2 minus the one that is below 51, I mean 15. So that gives us 7. So if that is 7, then that tells you that our mode will be 200 plus 4 out of 4 plus 7, you multiply by 100. But remember in the notes we had used initials B, B1, B2, and then tukakuja kutumia F hapo chini. I think I've already said that the numerator is the highest value minus the one above it, and F2 is the mode minus the one that is below it. So give me the mode. Two 36.36. 236.36. 236.36. The next thing that we have is called quartiles. Remember, quartiles divide data into 4 parts, and we have Q1, Q2, and Q3. So you can compute any of those. But I want us to compute Q3 for now. Now Q3 will be given as L plus 3N out of 4 minus CF. You divide by F, you multiply by W. That is the quartile 3. I've said it divides data into 4, that's why you're dividing by 4. So the first thing is to get 3N out of 4. And this is 3 times 100, you divide by 4. Three times 100, you divide by 4. What are you getting? $75. So that tells you the quartile class. The quartile class is where there is 75. So exactly here, it is 300 to 400. 300 to 400. So Q3 should then be 300 plus 75 minus the frequency above. The frequency above is 60. You divide by the frequency of that class, which is 15, multiplied by the width, which is 100. $400, I'm told 400 is the answer. $400. The next one is called deciles. Now deciles will be D1, D2, all the way to D9. Remember, deciles divide data into 10 equal parts. They divide data into 10 equal parts. So if I want to compute D8, for example, I will talk of L plus 8N out of 10 minus CF. You divide by F, you multiply by W. Multiply by W. So we begin by saying 8N out of 10. This is 8 times 100 divided by 10. That gives us 8. And that helps us to know that our decile class 8 is the 400 to 500. So our D8 is 400 plus 8 minus the frequency above. The frequency above that one of is 75. And the frequency of that class is 9. And the width is 100. The width is 100. $455.6. 455.6. So the last item I want us to remember how to compute is percentiles. Percentiles. Now percentiles divide data into 100 pieces or segments. So if I want, for example, percentile 92, percentile 92, it will give me L plus 92N out of 100 minus CF divided by F. Then you multiply by W. So 92N out of 100 will be equal to 92 times 100 out of 100. That gives me 92. So my percentile class is what? It is the class where I have 92. 92 should be, is exactly here. 500 to 600. 500 to 600. And therefore, my percentile 92 will be 500 plus 92 minus the frequency above, which is 84. We divide that by the frequency of that class, which is 8. You multiply by 100. Give me that answer. $600. So we stop there for now. We shall pick up from there tomorrow. Thank you.